Hi, I'm GUO CHENG GUANG, Primary 6 from YUMIN Primary School. In this time, we still have ordinary differential equations. But I want to recap on what I have explained for these. Well, what type of method are we using? Do you know what type of method? Well, of course, we have always been using it. So for that is the characteristic equations. Well, characteristic equations, when you keep on revising it. So let's revise what I have explained to you about these. Firstly, characteristic equations. Well, the first word, characteristic, comes from the word character. Character is just like a distinction. It's just like something to distinguish one thing from all the others. But in this time, what type or definition is this? Well, that's what I have just said. But this time, it's not just to distinguish one thing from all the others. It's using this type of method. Only this type of, well, ordinary differential equations can be solved. Okay. So, still explaining this by exemplification. So, explain it through this example. This example we have here, y third derivative minus 5y second derivative plus 8y first derivative minus 4y, and this is e to the power of x and e to the power of 2x plus 3 cosine x minus 7 sine x. Well, this looks pretty long, but are we sure that we can solve this? Well, I'm sure yes we can. Because firstly, let's analyze this. Firstly, according to this, linear, constant coefficient. Well, although this is non-homogeneous, but we can all first take it as it's homogeneous. Just that for non-homogeneous, since we want the general solution, so we split it. We split it into general solution for homogeneous differential equation and the particular solution for non-homogeneous differential equations. Well, yes, we can just split it like that. And that's what we have written a lot of times. YG is YH plus YP. This is what it is. Next, YH first. Well, now we don't say the method that we use. I'm going to tell you again how this method came from. Firstly, just imagine that we don't know that method. So how can we solve this type? We first take it as this is homogeneous. So that means it is 0. So if this part is 0, then the method we use here, you can say by substitution. Substitution is the first part of this. So substitution, what do you let? This let. We want all these add minus to cancel out. Cancel out everything. Now that means we have a few possibilities. Sine, cosine, exponential. But sine, cosine, exponential, which of them is the best? So for that, we write it as sine. Well, at first, the last lesson which I explained this, I write it as sine, cosine, and e to the power of x. But I want to add on a bit. Because x, they can have a coefficient. X can have a coefficient. So that means there can be something in front of this x. But now what do we use for? What do we use it as? We use lambda. Okay, So this is how we get all these. You can choose to use sine lambda x Yeah? You can choose to use cosine lambda x. You can choose e to the power of lambda x. You can use those. But which is the best? Sine. Differentiate cosine. Cosine differentiate sine. So then sine and cosine, they just get one another. But how about e? This exponential. Firstly, if this lambda, because lambda we're not sure what type of constant it is, but definitely is constant. But constant, there are a few different types. Firstly, real. Lambda is a real number. Second case, lambda is an imaginary number. Third case, it's a complex number. There's a mixture of real number, there's a real part, and there's an imaginary part. Yeah, that's possible here. Let's just think. For this exponential, if lambda is a real number, then differentiate, it's just exponential. If it is only an imaginary number, then you can use Euler's formula. Euler's formula. If it is I, then you get cosine and I sine. How about negative I? Well, it's just changed a little bit, but you still get cosine and sine. Okay, now you get cosine and sine. That means exponential function. You can get itself, the exponential function. You can get sine, you can get cosine. So that means it's all complete. So if these are all complete, that's what you want. You want the most complete answer or solution. You want it to be complete. So you choose this. Next part, just subbing it inside. But subbing it inside doesn't get what we exactly wanted. There's another part after subbing it inside. You see all these e to the power of lambda x. You see them? In all of these terms, they have. So how about, let's just simplify them. Okay, then you get this. Familiar? We just call this characteristic equations. But why must we use these? Is it actually very easy? Okay, let me show you this magic part. Firstly, the question you get is a long ordinary differential equation. Firstly, make it homogeneous. Then, okay, this is the first part, okay? Make a substitution. Simplify. What do you get here? Let me ask you a few questions. How many variables? One. One variable. One equation. Easy? It's what we learn in secondary schools. So that means the first part, I just changed this whole ordinary differential equation into something that we learn in secondary. It's just a simple algebraic equation with one variable. Now that's the magical part of these characteristic equations. That's the part why we use it. We change it from a very difficult thing to something simple. But in the future, we might learn more of these types of methods. Who knows? There might be more types. There might be other types that makes it easier or even makes it harder. But most importantly, we want the easiest. Okay, so let's go on here. But what's so different right now? 4 terms here. Now what can we use? When we have 4 terms, we have these 4 terms. Wait, how about we just use the factor theorem? and we want this part to be a 0. So let's experiment with this. Most commonly, we use 1, 2, 3, negative 1, 2, 3, all those. The numbers closest to, or even 0. But 0 in this case, definitely no, because here you have negative 4. So let's experiment a little bit. Okay, easy number, 1. 1 minus 5 plus 8 minus 4. Well, it's just perfect. 9 minus 9. 0. So that means 1 is one of lambdas. So that means one of this factor is lambda minus 1. One of these factors is lambda minus 1. So how about let's try the polynomial long division. So first of all, you get lambda cube minus 5 lambda square plus 8 lambda minus 4. Then here we have lambda minus 1. So you just treat this as just normal division. Well, you can think that it's just like this. Here, you get this. So that means this part, the other part, will be lambda square minus 4 lambda plus 4. Does this part look familiar? By cross multiplication if you want. But it's quite easy here. Get this. Lambda minus 1 times lambda minus 2 squared. Okay, so that means you just get like this. Okay, so next. Wait, and this part is gotta be a 0. So that means you get YH. YH. You have e to the power of lambda x. Well, you can choose to write c here, but just telling you, when you simplify, the c will simplify it off as well. So here, but you also have to know what are these lambdas. First solution, you get here, 1. How about second solution? Or the second root? But you have 2 of these. So it's the same as the third root. And they're both 2. Okay, the next you can get YH. So it's C1 e to the power of x. And what else? C2. But be careful, these two are the same. So you might want to bracket them together. Plus C3x e to the power of x. But be careful, here you have 2. Okay, then that means this is your YH. Next part is your YP. So I'll just use this space to get our YP. Okay, YP. So we have to let. But this might look quite complicated here. So we'll just let. Let's see. You have e to the power of x. You have e to the power of 2x. But here you have e to the power of x. Here you also have e to the power of 2x. YH. No. YP. If it is still like this, then at last, even if you find it out, no, it will not be right. Because if you just write it like this, then at last, even if we found it out, combined with this, 0. We've got to add an x here. Here you have just a constant. Here you have the x. Then next is the x squared. Okay. Next, sine and cosine. First derivative here. You have to be careful here, you have product rule, and then for the second time you have product rule, you have chain rule. Be careful here, the chain rule. Next up, the second derivative. Wait. Here, cosine comes negative sine. After that is the third derivative. Everything alright? Okay, third derivative. This part's 3 of these. Here you have a 4. Here you get an 8. Okay, so you get these 4 parts. Then next, you sub them back. But while subbing back, if you write everything down, you might find it a little bit long. So you might just want to regroup them. Okay? So firstly, from this part, you have e to the power of x. Firstly, here you have 3a. Minus 5 of this, 10a, add 8a. But a actually, because it's common in all of these, so you can just take a out. And you put it as a e to the power of x. Next, this part. So here, 1 minus 5 plus 8 minus 4, or this ax e to the power of x. Or later on, because here is 0, so later on we don't need to write this anymore. The next, but this is just for checking in case. Next is these 2. Well, you get 12 minus 10 of this b e to the power of 2x. it is bx times e to the power of 2x. 24. Okay, 40, 16. Perfectly again, these all cancel out. The next is the ones with square. So here's 8, here's minus 20, here's plus 16, and here's minus 4. Alright, so this part will also cancel out. After that, it's just the sines and cosines. So how about let's try the sine first. Sine, what do you have? D, then plus 5c, minus 8d. Okay, so that means this part is a minus 4c. Okay, wait, let me just write this. Okay, so this is for sine. Then after that is for cosine. Cosine, negative c. Negative c, negative. Okay, plus 5d. C is plus 8c. Then after that is minus 4d. And this is for cosine x. Then after that, this is equal to that whole thing. Okay, so I think this, because we have to be writing out those equations, so I'll write that on this side. So for all these equations, I'll just write it over here. First part, 3 minus 10 plus 8. Well, that's a 1. But it's for a times e to the power of x. So that means a, 1. Next. Okay, this part is 0. So here's a 2, 2b. Now 2b, what is it? Here's a 1. So that means b is a half. Next, okay, here 0, here 0. So it's the sines and cosines. So I need to write simultaneous equations for this. Sine. Sine, you have c minus 7d. C minus 7d, and sine is a negative 7. Cosine, 7c plus d. And this is 3. So next you might want to cancel out some of the things here. For example, this second part times 7, then you add this. So times 7, then you add this, that means you get 50c. And this will be 14. So then c would be 7 over 25. Then you can sub it into one of these equations. When you sub it into one of these equations, now think about what happens. For example, you sub it into the first, then you move it to the other side. Well, perfectly all divisible by 7, right? So basically that means b is actually a 1 add this thing. Okay, so let me see this. 26 over 25. Then that means you can put all of these that we have calculated here into yp. So yp, a, 1, so it's x, e to the power of x. B is a half. So it's half x squared e to the power of 2x. C is 7 over 25. Sine x. D is 26 over 25. So it's cosine x. Okay, next, but we want to find the general solution for this non-homogeneous differential equation. We have found general solution for homogeneous ordinary differential equation, and the particular solution for the non-homogeneous differential equation. That means we just have to combine these two to get our final answer. So YG. Well, you can combine some of the things. For example, e to the power of x. You can factorize both of them. So here, these two, you can combine. Now that is a sine and cosine. So that means this will be your answer. Okay, we're done. So for this time, I hope that you are clear so far. Okay, just take a quick look at all of these. Okay, so I hope that you're all clear. So you just have to be very clear of all of these. You need to be careful of each step. Okay, and most of these you can solve it. So if you like our videos, don't forget to subscribe to our channel. We'll see you in the next lesson. Thank you for your watching.